Hi, my name is Mary, and I'd like to share my CSCE 647 Project 1. So for this project, I made kind of a normal creator. So on the left-hand side of my project, you can see the normal map that the user's creating. And then on the right-hand side is where the final rendered image will be. So let me first talk about the features of my program, and then I'll get into the code just a little bit. So any of these dots on the left-hand side, you're able to manipulate. As soon as you manipulate it, it'll create curves, and you can see that your changes are updated in real time on the right-hand side. The base of this mesh, so this left-hand side is a triangular mesh where the position and the color are mapped out, and then the shader will and the GPU will fill in the actual image. This is based in WGPU, which is WebGL plus Rust and WebAssembly. So it can be hosted on online. It's also GPU based, so it hopefully gives a little bit more real-time performance. So anyways, you can modify the vectors. So this is based on a Hermitian curve where I have 4 points, and each point has 2 vectors that will connect and create a curve between the neighbors. And this is all in 2D, but you can create kind of cool looking shapes and shapes that look fairly 3D. So the mesh is interpolated using Coons patches, both the position. So there's a grid of 25 by 25 points inside of this surface. So each point is updated, the position is updated based on how close it is to the various edges, as well as the normal position. So each point has a color that corresponds to its normal vector, RGB. So the R component of the color is the x-axis, the G green component is the y-axis, and then B is the z-axis coming towards us. The z-axis is set by giving whatever value it needs to be in order to make the point a unit vector. So all of the vectors are unit vectors, and that's why you can see, like, here probably it's mostly the z component, here probably it's mostly the x component, here is y, and then everywhere in between for the various parts. Yeah, so the blue points control the vectors between the points, and the red is the actual position of the corners. And you can create some cool looking shapes. Yeah. This is also posted on my personal website. So you can use it on my personal website. I'll put a link in the description, and you might be seeing this on my website. So that's the creation of the surface. Now this yellow dot is the position of the light vector. So as you move around it in the screen, you can see that affects the diffuse lighting on the right-hand side of the image. And the further you get away from the center, so the center is 0, 0 on this left image. Further you get away, the larger the light magnitude, so the more desaturated kind of the right image appears. And then as you change its position, different parts of the surface are lit up. And again, this is all in just 2D. So the light vector is 2D, and the normal map is just an X and Y coordinate. And then I guess the normal vector is 3D, but the UV is just 2D. So as you move this, you can see how it affects the diffuse lighting on the surface. And then I'm still working on the caustic. So if you take a look behind the image, you can see a resulting caustic. I think that there's a bug behind here because that doesn't really look how I expect it to look. So I'll be working on that for project number 2. Yeah, so future ideas for this project is I'd like to be able to create multiple surfaces so that you can have a more interesting image. Right now, also the thickness looks very thin, so all of the surfaces you create have a very thin appearance. I'd like somehow for the user to be able to specify thickness, maybe material properties, as well as adding in shading, maybe some reflection, specular highlighting on top of the image. On the right-hand side, the surface is kind of base of a dark blue. And the light is white that's on top of it. So that's why you see a blue surface with white highlighting. I'd like there to be a UI that changes the color of the surface and the color of the lighting, as well as turns on the different lighting effects onto the surface. So you can create fun shapes. And let me refresh. If you keep the vectors the same, so the in vector and the out vector as like the same angle, the shape appears more blobby for lack of a better term. So you can create like droplets, bodies of water, looking images, stuff like that. Or you can create more sharp shapes that look more kind of like sheets of metal or sheets of different materials. Also, I'll be investigating this. I believe that you can see these jagged edges because of the order of rendering. So right now, when I'm rendering, I'll start at this corner, then go to this corner, top right corner, and then bottom right corner. So that's why if the renderer sees that I'm kind of trying to put something that was rendered earlier in front of something that was rendered later, it gets kind of this jagged edge. So I'd like to be able to dynamically decide the order of rendering for each point inside of the grid. I'm still investigating that. Yeah, so that's about all I wanted to talk about for the UI portion of this video. It is cool to create different surfaces. Now let's go check out the code a little bit. So the main math of this code is in this grid class. So this is all in Rust because it's WGPU based. So we create this grid. The first thing I do is create the corners. And then these bound points create the triangular mesh, and then any math after that is just updating this bounds point triangular mesh. There's also an index list that is created, and that just fills out the mesh with triangles. This apply Coons patch function does the interpolation. So this function interpolates both the position of the vector of the points inside of the grid and the normal vector. So for each point, I get the F0, F1. So that's the horizontal edges and the position of the horizontal edge, and the position of the vertical edges, and then this performs the interpolation. Since Rust has a vector class, I can just use vector math, and that makes this function look a little bit nicer. Then it updates the position. Once the position is updated, I then get the normal value using a similar Kuhn's patch update. In this case, I don't have to use the corner value, so that these P's are the corner positions. In this case, I just use the edges normals. And then for diffuse shading, I take that normal and I perform a dot product between the normal vector and where the light vector is, and scale that by this light intensity value. I found that if I used a full one, it was a little bit too oversaturated, and it didn't produce a really nice result. Once that's done, we assign the base color so that that right-hand side is rendered. On the lit grid, so this portion of this is that background image where I have the caustic getting created, and the background image is a 255 by 255 mesh as well, and it is for each pixel trying to sample the UV map on the left-hand side to see how the light gets reflected through it. I can do a little bit of this math again. In future projects, I'll be working on making this function better. So for each pixel in that 255 by 255 mesh, I take this theta value and sample from the UV grid. Once I have that UV grid sampled, I get the transmittance vector and take that transmittance vector, dot it with the light vector, same light vector as before. Again, apply a little bit of a scaling and add that to the background color in order to get the caustic effect. Yeah. Most of the other classes have to do with the UI and the rendering part, so I won't go into that too much. Yeah. Thank you very much.